So in the previous video for 7.7, we were working through example 2, and I mentioned that you can do this on the calculator. Well, in this video, we're going to see how these systems behave in the long term. And so it's really easy to see this on your calculator. So what I'm going to do is put this information into the calculator real quick and kind of see what behavior I see. So what I'm doing is I press second X inverse, and I'm in the matrix menu right now, and I go over to edit, and I edit matrix A, and I tell it it's 1, enter, 2, enter. And so our state matrix, if you have your notes from before, was 0.65, enter, 0.35, enter. And then I'm going to quit out of here, so I go to second and mode to quit, go back in. You have to do that on some calculators. Go over to edit. I'm going to edit matrix B right here, so I'm going to press 2 to edit matrix B. And I'm going to put in my transition matrix, so it's a 2 by 2 matrix. And so I'm going to say, okay, this is 0.85, 0.15, 0.05, and 0.95. Okay, so now what I want to do is I want to multiply these two. And so I press second and mode to quit. I'm going to go back into second and x to the minus 1 power for matrix, select 1 for A, go back in, select 2 for B, and multiply. So that was the first state matrix we got. So that was the percentage in 1 year. If I multiply this, so times the transition matrix again, I get what happens in 2 years, right? And the question asked for 3 years, and so what I did was I multiplied, went back in here, and got matrix B again. And I see that, remember, the percentage for n is that first number. It keeps going down, right? So if this keeps happening, the question is, how long? Does it just keep going down to 0, or does it eventually level out? So let's take a look at what happens on the long term. So I'm going to multiply again by B. So this would be in 4 years. Well, it still goes down. Let's see. Let's see in 5 years. Well, it's not looking good, right? They're down to 38%. Let's see in 6 years. Oh, okay, so it's 38 now, it's 35, but it seems to almost be slowing down. Let's see. I think I'm up to 7 years now. It's going down, but notice how it's slowing down as it goes down. So we're not seeing quite as steep of a drop. If this trend continues, we're starting to kind of level out. Somewhere around, it looks like maybe 30% or so. So the question is, what is the number where this levels out? So I keep multiplying, and I keep saying, I think I'm 10 years plus ahead now. Well, it goes into the 20s, but where does this level out? And so what we're looking for is something called a steady state matrix. And so we're talking about how to figure that out instead of by just sitting here multiplying over and over again, how to figure that out from actually doing some algebra. The formal definition of a steady state matrix is a state matrix that you can multiply by t, the transition matrix, and get the same state matrix back. In other words, every time you multiply it by t, nothing happens. You get the exact same values back. And so that would mean your system essentially leveled out. So we just saw a second ago that system dipped below 30% or so. The question is, where will it stop? Will it keep dropping, or what will happen? So not every population will reach a steady state, but the ones we will see will. So it will reach a steady state anytime you can say that your T is a regular matrix. And so there's some more explanation of that in the textbook. We won't really see much where we don't have this property. All right, so let's look at the first example we did, which is the one with the accidents. And so remember, the number of people in accidents seem to be increasing. The question is, where will it level out? So I don't know if you recall, but our transition matrix for this, T, remember it was accident, no accident, accident, no accident, .2, so you should have this in your notes, 0.8, 0.08, and 0.92. And so the question is, what would be the steady state of this system? So will this continue to where the number of people in accidents increases indefinitely, or will this level out at some point? So it is a regular matrix, so it will level out. The question is where. So using the definition, what we're looking for is a state matrix XY, such that when you multiply it by this, you get XY back, right? Essentially what I've just written down is an equation. And so if I have this equation, I need to figure out how to find the value of x and y. And right now, I don't know how to solve this kind of equation. I know how to solve things like with just x's and y's, but not with inside of matrices like this. So if you approach something like this, your best bet is to start simplifying. So on the left-hand side, what I could do is multiply to try to get this. Now, I can't do this in my calculator. I have to use matrix multiplication. So remember, matrix multiplication, rows hit columns, right? So this would be 0.2x plus 0.08y for my first entry. So this row hit this column. And then my next entry will be this row hitting this column. So it would be 0.8 x plus 0.92 y. And so this is supposed to equal x, y. Still kind of a strange system. I'm not really sure what to do with this, but if you remember properties of matrices, the only way two matrices can equal each other is if they're the same size, which we do have here, and the entries are the same. In other words, only if 0.2x plus 0.08y, the first entry here, equals the first entry over here. And same idea, second entry has to equal the second entry. Now I have something to work with. If you take a look at these two equations right here, I have two equations, two unknowns. They're both in terms of x, y. Now they've got values on the other side, so what I need to do here is move one of them over, or move the variable over. So I'm going to subtract x from both sides here, and I get the equation. So if I subtract x, I end up with minus 0.8x plus 0.08y equals 0. And then down here, I'm going to simplify by moving the y over. So I subtract y from both sides. I get 0.8x. And then if I have 0.92 minus 1y, I get minus 0.08y equals 0. Okay, so if you're an expert on solving systems of equations, you may look at this and see it's very bad. If you add these up, you get 0 equals 0. The reason is because they're the same equation. So really, I can only use one of these equations. It doesn't matter which one, so I'm going to use this one right here. But that means if I want to know what these values are, that I need to come up with another equation. And so anytime we're working with this, we're going to have the same thing come up. So we'll do this math and we'll pick one equation, and then we got to think of another one. But we can always come up with another equation by just thinking about properties of what we have. XY over here is a state matrix. That means that its entries have to add up to 1. So in other words, I know that x plus y has to add up to 1. And so now, if I solve this system of equations, I can find the value of x and y such that the state matrix using those two entries is a steady state matrix for this system. So let me clear the screen and we'll actually solve this. So I'll write down those two equations again. So I got minus 0.8 x plus 0.08y equals 0. And x plus y equals 1. So I got to solve this system of equations. Doesn't matter which method I use. I think the easiest would probably be elimination. And so if I want to solve using elimination, what I could do is multiply the second equation by 0.8, right? And then I'd eliminate the x's. So when I do that, I end up with the following system of equations. I got 0.8x plus 0.08y equals 0, and I got 0.8x, so negative 0.8, 0.8, plus 0.8y equals 0.8. So I got 0.88y equals 0.8. So y is going to be 0.8 divided by 0.88, which is a repeating decimal, so I'll just write down part of it. It's 9091. I'll round a little bit. All right, and so then what is x? Well, remember, x plus y has to equal 1. So this implies that x will equal 1 minus 0.9091, which will be 0.0909. So my steady state matrix, this isn't, I don't have an answer yet, right? So I need to actually write down, would be 0.0909 and 0.9091. And remember, this was accident, no accident. So this is my steady state matrix. So this means once the system reaches this point to where about 9.1% of people are having accidents and the rest aren't, then the system will no longer change based on these numbers. So if you multiply this times the transition matrix, you will get the same numbers right back. So once it reaches this state, it calms down, it stops changing. And so we don't have a situation where it always goes up forever. Eventually it levels out. So again, this process will always be the same. Anytime we want to find the steady state matrix, we'll go through this process. So what I want to do is I want to go back to the example we were working on with the marketing plan and see what the steady state matrix looks like for that one. So I'm going to go back to example 2, and I'm going to change the question here. I'm going to say, you know what? What I want to know instead is what is the steady state matrix for this system? So we already saw when I was playing on the calculator that over time that this seems to be dropping very quickly for N. Their market share is dropping very, very quickly. It dropped below 30% by what were we in, like the 13th year or something like that. So where will it stop? Well, let's go ahead and write down the transition matrix again and try to figure this out. So what I'll do is I'll stay in order of N and G. And so what we want to find is we want to find XY such that when we multiply by T, we get XY again. So if you look back in your notes, our transition matrix for this was 0.85 and 0.15 and 0.05 and 0.95. All right, so the first step is to multiply this through, and that'll give us 2 equations. We'll pick one of them, right? So I go through and I say, okay, I get for this row hitting this column, I get 0.85x plus 0.05y. And for this row hitting this column, I get 0.15x plus 0.95y. And this is supposed to equal x and y. Right, and so now I can set this equal to the first entry, this equal to the second entry. So I get my 2 equations, 0.85x plus 0.05y equals x, and 0.15x plus 0.95y equals y. As we saw before, when you subtract the x on both sides and the y on both sides, you'll actually end up with the same equation, just different signs, but it's actually the same equation. One is multiplied by -1. So 0.15x plus 0.05y, negative 0.15x, equals 0 from the first one, and 0.15x minus 0.05y equals 0 for the next one. So I pick one of these. It doesn't matter which one. I'll pick the first one. And then I add in the equation from the property of being a steady state matrix. The x and y have to add up to 1. And now I solve this system, and it'll give me the steady state. So I think I'll go with the same pattern I did before. Multiply this one by 0.15 and see what I get. So when I do that, I'll write them down here. The first equation will stay the same. And the next equation will be 0.15x plus 0.15y equals 0.15. So what do I end up with here? So I get down here, I get 0.2, y equals and this was 0.15. I didn't do a good job writing that down, 0.15. So y equals 0.15 over 0.2, 0.75. And so x and y have to add up to 1, so x equals 0.25. So my steady state matrix is going to be 0.25, 0.75. So this means if this trend continues, where it will level out is with N having a 25% market share. So we saw that on the calculator. It kept going down, kept going down. We saw it drop below 30%, but it was kind of slowing down. Turns out that'll keep happening until you hit 25% market share. So on your calculator, you can go and test that. You can keep multiplying, and you'll see that eventually it stops changing. So this process you should be able to do for any situation that you're given, as long as you have that property of a regular transition matrix, which we won't see a problem, an applied problem, where that isn't true.